Let's look at the problem in our notes that talks about the cholesterol levels of boys that are 14 years of older. The problem tells us that they have a mean of 170 and a standard deviation of 30. In this group of boys, or any group of boys at age 14, any level above 240 requires attention, meaning that they have extremely high cholesterol and some sort of an action would need to be taken. So we want to determine what percentage are greater than 240. So that is the start of our problem, obviously. We want to know greater than 240. So we want to know where x is greater than 240. That's the problem that we're looking at. We also want to look at the given information. So if we look at our normal curve has a mean of 170 with a standard deviation of 30. That tells us all the information I need to know. My x is 240, well, greater than 240. My mean is 170, and my standard deviation is 30. Now, before I actually go through and work out this problem, think about the problem to begin with and what kind of an answer I would expect. At 14 years old, do you think very many young men are going to have high cholesterol? Probably not. So we're not looking at a high percentage here. We would expect that a very, very low percentage of young men ages 14 would need to be on cholesterol meds or whatever the case may be. So just keep that in the back of your mind as you're working out this problem. So let's go to our standardized step. And you'll want to do all 4 steps when you're doing these problems. To standardize, we're going to use our formula x minus mean divided by standard deviation. Our x is going to be our 240. That's the number they give us that we're comparing to. We're going to subtract our mean, which is 170. That's what we're given in the problem. And we're going to divide by our standard deviation of 30. So x minus our mean divided by our standard deviation. Okay, so let's go ahead. This is going to give us what z equals. So I'm going to set this equal to z. That will give us at least a starting point here. So let's go ahead and plug that into our calculators. You're going to want to take 240, and you're going to want to take 240 minus the 170 first and hit equal. And then you're going to want to take that, which it should be 70, and you're going to divide by the 30. And I get approximately 2.33. So that is my z value. My z value is 2.33. That tells me on my normal curve that I'm just over 2 standard deviations away from my mean. So let me see, I'm going to turn over here so I can do some drawing on here for you. Okay, so when I'm looking at my normal curve, I know that my mean is right down the middle. So let me take my pen there. There we go. My mean is right down the middle. That's going to be my mu. And we're looking at approximately 2 standard deviations. So I would go maybe approximately here. I mean, look at your normal curve and estimate. It's a really bad line, excuse me. So you'll draw your line 2.3 standard deviations to the right. And we want to look at greater than. So we're looking at this little bitty tail over here. Again, would we expect a high proportion or a high percentage of young men to have high cholesterol? Probably not. So we are looking at a very small number to our right there, 2.3 standard deviations away from our mean. And that's all you need to do for table A. And what I would recommend doing for your normal curve is to actually just copy and paste a normal curve over from the internet. Just Google normal curve and you can copy and paste one over. So now we want to go to our table A and use our z equals 2.33 and look that up in our table A to find our percentage. So you're going to go down the left-hand side of table A in your book. Mine's on page 691. You'll go down the 2.3 column and then you'll go over, or the 2.3 row, and then you'll go over to the 0.03 column. So you'll get a number of 0.9901. Okay, that's 2.33. When we are dealing with our table A, that is giving our proportion to the left. So that 0.9901 is giving us everything over here to the left. So everything that's not shaded is about 99% of the table. Since we're looking at just this little bitty tail, we want to take and subtract our number from 1. Okay, we want to take our 1 minus our 0.9901. And you will always subtract if you're looking at greater than. If you're looking at less than, then you will use the number given. So if we were looking at what proportion are less than 240, then the 99% would be okay. Since we're looking at greater than, we need to subtract. And when we do that, we get 0.0099, or approximately 1% of young men have a cholesterol greater than 240, meaning that they would need some sort of treatment or medication or something along those lines.